For centuries, people have wondered how the mind processes numbers. Are numbers just symbols on a page? Or is there a physical center in the brain where they truly come to life? For a long time, answers came only through observation, especially from people who had suffered brain injuries. These strange and specific symptoms became the first clues. A mathematics teacher, after suffering a brain hemorrhage, could still read and speak. But when asked to solve a basic addition like 3 plus 4, he just stared, silent and confused. This showed that mathematics wasn't just abstract thinking, it was processed by specific structures inside the brain. Over time, more cases emerged. Some people couldn't read numbers. Others lost their sense of numerical order, and in every case, the damage was concentrated in similar regions of the brain. But these were only clues. The real breakthrough was yet to come. In the late 1980s and 1990s, a revolution took place in neuroscience. The brain was no longer a mystery hidden behind the skull. With a new technology called functional magnetic resonance imaging, fMRI, scientists could now see the brain in action, live. Researchers gave volunteers simple math problems. Which number's bigger? Add 3 and 5. What's half of 12? Each time the same brain region lit up, a narrow groove near the top rear of the brain, the intraparietal sulcus. This area turned out to be central for comparing quantities, estimating size, and performing basic arithmetic. But that wasn't the whole story. For more complex operations, the front part of the brain lit up. The prefrontal cortex became active during multi-step reasoning, problem-solving, and decision-making. Some math questions involved language, like, Tony had 3 pencils, then got 2 more. When people heard word problems like this, yet another area responded, the angular gyrus. This region acted as a bridge between numbers and language. Mathematics wasn't just about calculating, it was about communicating. The brain became an orchestra during a math problem, each section playing its part, numbers, logic, and words, all in harmony. Scientists then turned to children, and even animals. In young children, when asked to compare numbers, the same brain areas lit up. In studies with monkeys, similar activity patterns appeared. This showed that number sense wasn't just a learned ability, it was part of the brain's evolutionary architecture. But not everyone experienced numbers the same way. Some people had an unusual struggle with math, despite normal intelligence. These individuals were diagnosed with dyscalculia, a learning difficulty that often links to structural differences in the intraparietal sulcus. This confirmed what educators long suspected. Math learning is not one size fits all. Every brain works differently, but every brain can grow. In recent years, researchers have shown that practicing math actually strengthens neural connections. Especially in young children, repetition and structured learning lead to physical changes in the intraparietal sulcus in prefrontal cortex. Mathematics is no longer seen as a talent you're born with. It's a skill, like a muscle, that grows with use and shrinks with neglect. Today we know that numbers aren't just written on paper. They live in the brain. They are processed, stored, and even reshaped by how we think. And behind every math problem lies a silent but powerful symphony inside the human mind. Mathematics is not born in the mind, it is born in the brain.